Hello friends, welcome to Zeta Axis, and today we will discuss about earthquakes. We will see how earthquakes are formed, what causes earthquakes, what are different types of earthquakes based on depth, the distribution of earthquakes around the world, the effects of earthquakes, the steps we can take to mitigate earthquake and seismic zones in India. We will see the different scales which are used for measuring earthquakes. Now let's see how earthquakes occur. We already know that our lithosphere is divided into different plates, and each of these plates moves with independent velocity in independent direction. At the plate boundaries, because of this independent relative velocities, tensions may develop in the rocks. Here we see that the plate is subducting, while the other plate is moving towards the boundary. And because of this, we can see that tensions will develop in the rocks over here. This plate, which is moving downwards, will try to move these rocks in the downward direction, and therefore there will be some tension developing over here. We can see that there is some tension here and it continues for several thousands of years. This tension will build up. Eventually, the tension will become so high that they will snap. You can see here how these rocks have snapped and a crack has developed. Now, elastic rebound theory says that when the rock snaps, it will try to come to its original position. So it will be something like this. And it is this sudden motions which creates the seismic waves. Now let's see the whole process from the beginning to understand it better. Here we can see that this plate is subducting. The rocks over here are coming in tension. Eventually the tension will become higher and it will break. It will become a crack, and because of the elastic rebound theory that it will try to come back, it will generate a seismic wave. This seismic wave will be emitted in all directions and they will flow throughout the earth crust as well as asthenosphere. Now here we can see the point from where this energy was released is called focus or hypocenter. The point directly above this focus is called epicenter. This is the point on the surface closest to the focus. The waves which are emitted at the focus are called body waves. These body waves, when they reach the surface, they create another type of waves which we call as surface waves. Moreover, body waves are not of only one type, but two types of body waves are emitted. Here we can see that the green one is slower than the yellow one. The yellow line indicates P waves while the green line indicates S waves. Now let's quickly revise how earthquakes occur. Tension builds within the rocks due to relative motion of the plates near faults or boundaries. This tension could build over hundreds of years, in fact thousands of years. Tension is released suddenly by breaking and movement of rocks. So when the tension exceeds, the rock would snap. Elastic rebound theory says that broken rocks immediately try to reoccupy its original position. What it says that when the rocks break, they will not stop here. It's like this. They will try to reoccupy its original position. In fact, sometimes there could be certain other vibrations, like it could be, and because of this we see tremors. Body waves are generated at the point where rocks release energy. This point is called focus or hypocenter. This is generally below Earth's surface. In fact, it is always below Earth's surface. Epicenter is a point on surface directly above focus. Epicenter is the closest point on surface to the focus, and epicenter is the point where body waves first reach the surface and they form surface waves. Surface waves are formed when body waves reach surface. Now what are body waves and what are different types of body waves, as well as what are surface waves and what are different types of surface waves, we will discuss in seismic waves video. Now let's see elastic rebound theory. Elastic rebound theory says that the rocks within our earth crust are elastic because they are under heavy heat and pressure, and therefore they can be stretched or pulled. But when the tensile forces exceeds a limit, these rocks will break. They will snap. Broken rocks try to immediately come to initial position. That is, when a rock breaks, it will try to come back to its initial position. This causes rapid earth movements and it generates seismic waves. So this is what is elastic rebound theory. Now let's see our first cause of earthquake, that is faults and fold. Faults and fold are created by the movement of earth due to endogenic forces. So it is the forces within the earth that creates faults and folds at certain locations. Faults and folds can occur by activities other than plate tectonics. For example, hotspots, when they reach the lithosphere, they create a bulge in the lithosphere. When a bulge is created, certain cracks can be seen in the landmass. Moreover, when a plate is undergoing subduction, the whole plate is under tension, and a fault can develop at regions far away from the boundaries. Narmada River fault, Tapi River fault are the examples of this kind of faults, where because our Indian plate was subducting under Eurasian plate, the whole landmass was under huge tension, and it was at the Narmada fault that a crack occurred. Fold rocks can also form faults if pressure increases. Here you can see a recumbent fault. The rocks are undergoing a folding process. If this applies a pressure which is greater than the capability of rocks, then rocks will develop a fault. Now when a fault develops, it may happen that rocks on the different sides of fault have relative movements. They could have relative velocities. Because of this, there could be tension generated in the rocks, and once this happens, the rocks can snap in a sudden. Here we can see a fault. This block of landmass is trying to move down, and this block of landmass is stable, or it is trying to move in upward direction. The rocks on both sides of this fault are moving relative to each other, and therefore some kind of tension exists. This tension could be released suddenly with high amount of energy, generating earthquakes. We have already seen that volcanicity can also create earthquakes. Rising magma as well as gases, they apply a force on the above lying rocks. This causes breaking and melting of the crust lying over, and this leads to a kind of tremors. So when the lava tries to come up, it will try to melt and break the overlying rock structures, and when these rock structures are broken down suddenly, they can create vibrations. However, the region they affect is very small. Plate tectonic activity is the most common cause for earthquakes. We know our lithosphere is divided into different plates, and each plate moves at different velocity with respect to each other. Therefore, at the boundaries of these plates, we can see that tensions could occur. These tensions could lead to snapping of rocks, generating earthquakes. Here we have plotted a map of earthquakes occurring around the world. The green dots indicate the shallow earthquakes, that is earthquakes occurring at less than 70 km. The brown dots indicate intermediate earthquakes, that is earthquakes occurring from 70 to 300 km depth. And the pink dots indicate deep-seated earthquakes, that is earthquakes occurring at a depth of 300 or more. Now you can see all these earthquakes are concentrated on the plate boundaries. So we can see that plate boundary is definitely the biggest cause of earthquakes in the world. We have already seen that our Earth's lithosphere is divided into 7 major plates and several minor plates. Plates move relative to each other, and therefore there are tectonic events at the plate boundaries. At the convergent boundary, we see that an oceanic plate here is subducting. This subducting plate extends very deeper in the asthenosphere. This provides deep-seated earthquakes. Here we can see that earthquakes can occur due to certain activities within the plate, and this could create very deep-seated earthquakes. This region is called Benioff zone, and the depth of these earthquakes could extend till 670 kilometers. Now let's quickly see different causes of earthquakes at plate tectonic boundary. We have already seen that Earth's lithosphere is divided into 7 major plates and several minor plates. Each of these plates move relative to each other. All tectonic events occur on the plate boundaries because tension builds on these plate boundaries due to relative movement of plates. In this map, we can see that all the seismic activities are concentrated on the plate boundaries. including earthquakes and volcanoes. You can see here that they are concentrated on the plate boundaries. Now let's see a convergent boundary. At convergent boundary, what happens that this oceanic crust is subducting. This subducting plate extends to very great depth in the asthenosphere. Earthquakes which generate from here are deep-seated. They could be as deep as 670 km. Remember, from 670 km, our inner mantle starts. This region from where deep-seated earthquakes is generated is called Benioff zone. Mountain building, faulting and violent volcanic eruptions occur on the convergent boundaries. We can see here, this is called Pacific Ring of Fire. In this region, Pacific plate and other plates are subducting to the continental plates. And because of this, on the margins of the continental plates, we see a lot of mountain building activities as well as volcanic activities. Next is a divergent boundary. A divergent boundary is created when two plates move away from each other. A fissure is created and lava comes to the surface from these fissures. A lot of transform faults are also seen on the mid-oceanic ridges. At these boundaries, we see only shallow earthquakes because the plate is very thin here. You can see because of the upwelling magma, the plate has been thinned due to melting. And because the plate is thin, only shallow earthquakes occur here because no earthquake occurs in asthenosphere. Because asthenosphere is ductile, it is in semi-solid state. So no earthquake can occur in asthenosphere. Now we see a transform fault. In a transform fault, relative movement of rock layers occur. They move with respect to each other. This could create a lot of tension in the rocks. San Andreas fault is a very good example of this, where we see very large number of earthquakes occurring. At transform fault, generally shallow or intermediate earthquakes occur. Here is the summary of the causes of earthquakes we discussed. If you want to note them, you can pause the video. Now let's see reservoir-induced earthquakes. These are man-made causes of earthquakes. What happens here when we build a dam? Water collects in the dam. When the water rises, it exerts more pressure on the rocks above and then it causes a fracture within the rocks. This releases a lot of energy and earthquakes are formed. Koyna earthquake of 1967 is an example of reservoir-induced earthquake. Now let's see different types of earthquakes based on depth. Shallow earthquakes are the earthquakes where focus of the earthquake is located at a depth less than 70 kilometers. Because it is close to the surface of our earth, maximum energy from the earthquake reaches our surface, creating large destructions. The effect felt is in small areas, and we can see this kind of earthquakes in all the three types of boundaries. Next is intermediate earthquake, where the depth of the focus of earthquake is between 70 to 300 kilometers. These kind of earthquakes occur at transform and convergent boundaries. The reason why intermediate earthquakes do not occur at diverging boundaries is that the upwelling magma melts the lithosphere and makes the lithosphere very thin. As earthquake cannot occur in asthenosphere, therefore no intermediate earthquake is possible here because there is no lithosphere below 70 km. Deep earthquakes are the earthquakes where depth of the focus is greater than 300 km. Most of seismic wave energy released by these earthquakes is dissipated till it reaches the earth's surface because the distance is very high. These kind of earthquakes occur at convergent boundaries only because at the convergent boundaries we have a tectonic plate which is subducting and this plate extends very deeper in the asthenosphere. In the divergent as well as transform boundary, we do not see tectonic plates in the deeper parts of asthenosphere. Therefore, no deep-seated earthquakes is possible at divergent and transform boundaries. Effect of these earthquakes can be felt in larger areas. The deepest earthquake recorded is 670 km, that is almost from the starting point of inner mantle. We have already seen this map which shows us different types of earthquakes, that is the green color indicates shallow earthquakes, the brown one indicates intermediate earthquakes and the pink color indicates deep-seated earthquakes. We can see that All these earthquakes are concentrated on the plate boundaries. However, at the subducting margins, we see deep-seated earthquakes, both here as well as here. The earthquakes can be divided into three main regions. The first is Pacific Ring of Fire. The another is Alpide belt, that is Alpine-Himalayan orogenic region or mid-oceanic regions. Pacific Ring of Fire or Circum-Pacific Belt is the region surrounding the Pacific Ocean. You can see the Pacific Ring of Fire in our pink colored belt on both sides here. Now this is a region where a lot of seismic activities occur. Both volcanism and earthquakes are concentrated in this region. So let's see why so many seismic activities are concentrated in Pacific Ring of Fire. We know that almost 65% of all earthquakes in the world occur in Pacific Ring of Fire. It includes western parts of North America and South America. It includes eastern parts of Asia as well as New Zealand, but it does not include Australia. Important causes for high earthquakes in the region is large number of continental and oceanic plate boundaries. We see in the west side of our Pacific plate we have Eurasian plate and Pacific plate boundaries, as well as Pacific and Indo-Australian plate boundary. On the east we have American and Pacific plate boundary, as well as Nazca and South American plate boundaries. So we see that a large number of continental and oceanic plate boundaries exist, where the oceanic plates are subducting under the continental plates, creating a huge seismic area. Fold mountains are formed all along the boundaries. Now we see that Rocky Mountains, Andes Mountains are formed around these boundaries. Now where fold mountains are created, the land mass is under huge pressure and faults may occur here, which could create earthquakes. There are a large number of active volcanoes in this region, as well as subduction zones are there at the continent and ocean plate boundaries, and because of these regions the Pacific Ring of Fire is a very seismically active zone, and because of this we see deep focus earthquakes occur here because of the subducting zones. The second region is Alpide belt. This Alpide belt is the Alpine-Himalayan orogenic region. Here we see that this region extends from Indonesia, it passes through India and then it reaches Europe. So you can see this whole Alpide belt. This is called Alpide belt because all the mountains in this belt had origin at the same time. They all originated together. It includes Alps, Himalayas, Zagros, Elburz and several other mountains. So let's see why so much seismic activities occur in Alpide belt. We know that almost 21% of all the earthquakes in the world occur in Alpide belt. It includes South Asia, West Asia, Indonesia, regions adjoining the Mediterranean in Europe and Africa. The reason why so much seismic activities occur here is because it is a fold mountain belt. We see Alps, Zagros, Himalayas, Aconcagua, all fold mountains in this region. Now because fold mountains are created here, land masses are in huge tension and faults can occur there. When faults are created, earthquakes are generated in those regions. That is why these regions are rich in earthquakes. Moreover, subduction zone occurs because Indian, Arabian and African plate is moving towards Eurasian plate and they are subducting under the Eurasian plate. And because of this, earthquakes occur because at the subduction zones, we know that lot of tension exists between the two adjoining plates. The next region is mid-oceanic regions. Here we see moderate or shallow earthquakes occur. They are caused due to the large number of transform faults and fractures in the plates here. Here it is a diverging margin and the plates are moving away, because of which there are a lot of faults in the plates. And we see fissure type volcanoes, so magma is also trying to come up, and because of all these regions we see that large number of shallow earthquakes occur here. Now let's see effects of earthquakes. Earthquakes can cause landslides. They can shake the earth and can cause slope instability. This leads to downward flow of debris. What this means is that if there is a hill and there is a slope, rocks or slants are lying over here. So because of this earthquake, they will start to flow downwards. Now today, because of deforestation and large amount of road construction in hilly regions, we see large amount of debris lying on the slopes. Earthquake can cause flow of this debris downhill. Tsunamis are created by earthquakes in the oceanic flow. These earthquakes in the ocean flow create waves on the surface. These waves travel at a very high speed towards the coastal region, and when they reach the coastal region, their height increases. This is called tsunami. We have discussed tsunami in great detail in another video, the link for which should be available over here. The tsunami of 2004 was created by an earthquake in Sunda Trench. Flash floods can occur because of earthquake. The landslides can block the narrow channel of rivers, creating a natural dam. This dam blocks the flow of river and creates a reservoir in the upstream direction, thus leading to flood in the upstream direction. Earthquakes can also cause breaking of dams. Soil liquefaction. When cohesionless or partially saturated soil substantially loses its strength and stiffness in response to earthquake. So what happens if we consider these rocks which are not attached to each other but they are arranged one over the other and they are partially submerged in water. Now when earthquake will occur, we will see that it shakes the whole structure and these rocks will settle down or they will come down. They lose their strength and stiffness in the face of the applied stress. And because of this, the earth's surface will collapse. We will see liquefaction of the region. This can lead to collapsing of buildings. Avalanches can occur in snow-covered mountains. Even damage to buildings and properties occur due to earthquakes. Now let's see what are the steps government should take for mitigating effects of earthquake. They should establish earthquake monitoring centers, which is called seismological centers, for regular monitoring of earth-related matters. Fast dissemination of information among the people in vulnerable areas. Now you see, the earthquake travels at a speed, but this speed is less than the speed of electromagnetic waves. So if there is a monitoring center, it can provide few seconds or even minutes to people to evacuate the area or to go to safe locations. Vulnerability, risk information and dissipation. Government should analyze which area has high risk probability of earthquake and which has low. Based on this, it should inform people and educate people. Public awareness may be created in people that what steps they should take in face of earthquakes. Building codes and designs should include earthquake resistant structures. They should limit the height of building in these areas. So it should be made mandatory by government that in these regions there must be some earthquake resistant steps that must be included in the building. In fact, the height should also be limited. House types and building designs can also be changed to mitigate the effect of earthquakes. Now these are the seismic zones in India. This is the old seismic zone map before I think 2003, and this is the new seismic zone of India created in 2002. So you can see that there is slight difference in these two maps and we see different zones according to their color. We have mapped different cities to this zone, so you can use this map to correlate the cities along with their zones. You can see which cities are in which zones. This could be an important question for your exams. We can see major cities. They can ask which major city like Kolkata or Srinagar or Mumbai, all these cities lie in which zone. Now in this map, we have shown the mapping between the seismic zones as well as the faults in our Indian plate. We know that because of the boundary of Eurasian and Indian plate, we have a very highly active seismic zone here. We see that some regions are in zone 5 while others are in zone 4. Similarly, here we have Narmada Valley fault. There is Mahanadi fault, Godavari fault, and along these regions also we can see that zone 3 exists. We already know that this Kutch region is also in zone 5 because here is our boundary of Indian plate and Eurasian plate. These are some of the cities and their seismic zones. If you want to note them down, you can pause the video. Now there are different scales to measure earthquakes. They are basically divided into two categories. The first is magnitude based scale. Here what we do, we measure the magnitude and energy of earthquake to classify the earthquake strength. It takes into account the energy and the magnitude. The magnitude is the maximum vibration caused by the earthquake. It generally uses a formula for calculation. Richter scale is an example of magnitude based scale. There is another scale which is called intensity based scale. Here we do not take into account the magnitude or energy, but it is based on observations. Here we see how much destruction is done, how much buildings have collapsed, and other effects of the earthquakes on the surface of the earth. Classification is based on the effects the earthquake have had on the surface of our earth. Mercalli intensity scale is an example of this kind of scale. Now let's see Richter scale. Richter scale is a logarithmic scale. It has this equation where A depends on the magnitude of earthquake measured on seismograph, while A0 indicates the distance of the measuring station from epicenter. So it depends on two values. This is a seismograph measurement of an earthquake. So Richter scale will use the maximum amplitude of all the waveforms for measuring the earthquake. Here, this is the maximum amplitude of the measured earthquake, and this will be used by Richter scale. It is based on magnitude we have already seen. It has no upper limit, but the strongest recorded earthquake is 9.6, which occurred in Chile. Now, if there is 1 unit increase in the Richter scale, that is a 7 unit Richter scale earthquake is 10 times more in amplitude compared to a 6 unit Richter scale earthquake. Magnitude is measured by maximum height of wave. We have already seen that this is the maximum height of the wave, and this will be used to measure the magnitude, which will be used in Richter scale. Moreover, for 1 unit increase, that is a 7 unit earthquake is 32 times releases more energy compared to 6 unit earthquake. Now what is the difference between amplitude and energy? We have seen for amplitude measurement we will take the highest value of the waveform. But for measuring the energy, we have to measure the energy in all the waveforms. We can see that there are so many small and big waveforms. So all these waveforms will be counted in calculating energy. So for 1 unit increase in Richter scale, 32 times energy is released. We know that certain shortcomings exist in Richter scale. The magnitude calculation depends on the location of earthquake. So if it is very far away, the values could be saturated. Even the seismograph might not be able to measure the earthquake properly. Moreover, the magnitude measured depends on the type of seismograph. Different types of seismograph can give different measurements for same earthquake. It cannot calculate the amount of energy released by earthquake. And the equation used for Richter scale saturates on higher scale. Therefore, there is a saturation for higher earthquakes. They saturate, that is, they show less difference in high intensity earthquakes. Moment magnitude scale has been used since 1970. This is different than Richter scale, but it is mainly reported in media as Richter scale. This has abandoned the use of peak wave amplitude. Notes for all the topics that we discussed will be available on our website zeta-access.com. Thanks for watching the video, and if you like the video, please like, subscribe and share. If you like our effort and like what we are doing, then you can use our UPI ID or Patreon ID to support us. You can follow us on our social media links. Until then, we meet again. Jai Bharat, Jai Gyan. Thank you.